Good day. In our last class, we discussed differentiation as an art of finding the derivative of a function. So today, we want to look at some of the rules under differentiation. When we say rules of differentiation, we mean the algebraic properties under differentiation. These algebraic properties include addition and subtraction, product, quotient rule, chain rule, and what have you. Okay, so we'll be looking at this one after the other. So we'll start with the sum and difference rule. So we'll label this A. Okay, so when we say sum and difference rule, we mean when we have two differentiable functions, whose relationship is either sum or difference. Okay, so we want to see whether the a function under the sum and difference also whether it is differentiable or not. Okay, so here we'll consider two functions. We say suppose u of x and v of x are differentiable functions such that y is equal to u of x plus or minus v of x. Okay, so under this law or rule, we say that the total derivative of y with respect to x is the same thing as the derivative of u with respect to x plus or this preserve the sum and difference. Okay, plus or minus the v of x. Okay, so anytime we have two addition or subtraction of two functions, we want to see whether the slope of such a functions exists. Okay, so although it is exists, if it exists, this is how it is given. So let's see the proof of this. So the proof so we say suppose that u of x and v of x are differentiable. Okay, are differentiable. So when we say both of these functions are differentiable, the meaning by the definition of derivative is that that is their derivatives exist. Okay. Okay. So by the previous definition, if the derivative of a u of x exists, what it means is that the u dx is equal to the limit of u of x plus h of x, u of x plus h minus u of x is divided by h at h tends to 0, and the v dx. Okay, the limit v of x plus h of v of x plus h minus v of x divided by h. Okay, so this is what it means if the derivative exists at any point of x. Okay, so So this means that the derivative exists, and that by the antecedent of the rule we stated earlier. Okay, so we have that. Want to see if y is given as the sum or difference of two functions. Want to see whether dy dx also exists. Okay, so if y is given as this, want to see whether y exists. Okay, and of course, from our antecedent, we know that the derivative of this u exists, the derivative of this v exists. So we want to see whether the sum of these two also exists. Okay, and the sum, which is y, we want to see whether it exists. Okay, so we need to find what is the y dx. Okay, so by definition, okay, y is given as this, so it means this will be given by u of x plus h plus or minus v of x. Okay, that is this term here. Okay, when it vary. Okay, so these are it is. So minus u of x plus or minus v of x. So by definition of derivative, this is what we have. Okay, so let's simplify this further and see what it gives. Okay, so this is equal to the limit as h tends to 0. So we open the bracket here and group this time in terms of u and v. So we have u of x plus h minus u of x when we open the bracket. Okay, so plus or minus v of x plus h minus v of x. Okay, so when we open this bracket, okay, and factor out the plus or negative this. So this is what this one gives. Okay, so everything over h. Okay, so this h, okay, by since the denominator of this, since both v and u share the same denominator. Okay, so let's do this once and for all by distributing the denominator on them. Okay, and give this a bigger bracket. Okay, so by the limit property, okay, so this limit affects this term, on it also affects this term. So we can split the limit on this, so that this will be okay. So plus or minus according to the limit law. Okay, so what we have here is okay. Then this will be this. Okay, so by definition we have earlier. Okay, earlier we said the function u has a derivative and the function v also has a derivative. Okay, so by definition, okay, so this means the u dx. So plus or negative, this also means the v dx. Okay, so this is why we say that if u and v are two differentiable functions, okay, so and y is given as u plus or negative v. Okay, so y is also differentiable for the same value or any given variable of u and v. So let us now state that so we only consider two variables there. Okay, this also holds for more than two variables. Okay, so but we will state this as as a proposition, okay, and the proof can be inferred from what we just finished here, okay. So see, so if u of x, u of x, and w of x are differentiable, okay, so such that y is the addition or subtraction of the three functions, okay, so we say then the derivative of y with respect to x, okay, also exists. Okay, so the derivative also exists. Okay, so this can be also be extended to 4 functions, 5 functions, and what have you. Okay, so this can also be proved using the concept in the previous rule. Okay, so let's now see a few examples under the sum and difference rule. Example, let's say example 1. So differentiate y equal to exponential x plus cos x with respect to the argument x. Okay, so we say solution. So we are given y equal to exponential x, okay, plus cos x. Okay, so if we compare this function with the first function we considered earlier, so we can regard this as a function u of x, and we can regard this as a function v of x. So if we apply the sum and difference here, we have chosen the operation here to be sum. Okay, so if you apply that, so the derivative of exponential x, okay, with respect to x is exponential s, okay. Just the same way the rules preserve the sign, okay. So this possibly will remain, okay, and then when we differentiate this with respect to x, this is negative sign x, okay. So we'll open the bracket here, so this is this, okay. So this is how we apply the sum and difference rule. So let's see another example. Okay, so this time let's consider the case of 3 functions. If you are given, okay, so you want to see example 2, you equally want to find the derivative of this function. Okay, so this short note means with respect to x. Okay, so let's see this quickly. So here also we are given 3 functions. The first one is x to the power 5, the second one is x to the power 3, the last one is x. Okay, so again, we can regard this function as a function u, the function this as a function v, and this as a function w. Okay, so if you apply the law, okay, we differentiate each of these function with respect to the argument x. Okay, so if we differentiate this, okay, using the power law we have described in our earlier video, okay, we'll see that the power we'll come down, we'll remove 1 from power. So this is this. Okay, again, for the same power law, this becomes this. Okay, so since the power of this is 1, okay, so if we differentiate this, okay, 1 comes down, and then what will be here will be 0. So and by law of this is 1. Okay, so again, this is the derivative of this function. Okay, so this is so because we have said earlier that this is a differentiable function, a quintic polynomial is a differentiable function. A cubic polynomial is also a differentiable function, while linear function is also a differentiable function. So it is possible for us to find their derivative, okay, when both of them, or when the 3 of them are associated with either positive or negative. Okay, so that is that. Okay, so we can consider more than 3 functions as we have said earlier. Okay, and, okay, let's give an example like that. So if I do this function, so again, we want to look at this. Okay, so we can regard this as a function separate from this is a logarithm function, a natural type, exponential function, which is an antilog of this word, they are of separate type. This is a quadratic function, and this is one of the trigonometric function. Okay, again, we are given this in separate form. Okay, so we can similarly apply the law into this. Okay, so for each of the function, we differentiate them with respect to the argument. Okay, according to our previous video, the derivative of ln x is 1 over x, and the derivative of exponential x is exponential x, and the derivative of this using the power law. Okay, so this is 2x. Okay, and the derivative of this, okay, also in our previous video, we have got this to be cos x. Okay, so this is the derivative of this function, okay, under the sum and difference rule. Okay, we'll stop here, and in our next class, we'll look at other types of rules of differentiation called the product rule. Thank you.